Okay, welcome everybody. So I'm going to teach you today the last part of the chapter, which is on significant figures. And to understand significant figures, there's two things that you have to be aware of. The first thing is that you need to be able to determine the number of significant figures in a value, and the other thing is you need to be able to, when you perform an operation like multiplication, division, subtraction, addition, you need to be able to then round to the correct number of significant figures. Now remember, if you look back in the notes, significant figures, it relates to a measurement. It's based on the measurement that you make. When I take a measurement, I need to be able to round the number with the correct number of certain digits and uncertain digits. Together, when we add the certain digits and the uncertain digits together, that gives us the number of significant figures. Now, a lot of times, though, significant figures are kind of removed from the measurement. You're given some kind of calculation or a number, and you're asked to determine the number of significant figures in that value. And so there's some rules that you need to follow. These are the two rules that are most important. All digits that are not zero are always significant. So that's rule number one. If you have digits that are not zero, they're always part of the measurement, they're always significant. If you have zeros, they're going to be significant when they're between two numbers. But they tend to be insignificant or not important when they're at the end of a number. But it depends on if there's a decimal present or not. And so when there is a decimal not present, so no decimal, the zeros on the right, the ending zeros, these are the zeros on the right-hand side, are not significant. When you have a decimal present and you have zeros in the beginning of the number, usually the number is less than 1. You'd have something like 0.003060. The zeros on the left, the starting zeros, are not significant. However, these values are. These zeros on the left, they are called placeholders. Now, are you confused by this? Well, you might be. So, why are some zeros significant, some zeros aren't? It has to do with the idea that some of them are acting as placeholders, other ones are acting as important numbers, significant values within the number. So there's a nice rule, a nice shortcut to take that will help you to kind of get through the significant figures. And I call it the Atlantic-Pacific Rule, and it's on the next slide. In your notes, it's a little bit out of order. I moved it in my notes to go along with this. So the Atlantic-Pacific Rule kind of summarizes how to deal with zeros. If there's a decimal point present, then you start counting from the left side of the number, the Pacific side. And you skip all the leading zeros. If a decimal point is absent, then you count from the Atlantic side, from the right side. And you would skip all the trailing zeros. So when you do this, you need to make sure that you tell if there's a decimal present or not present. And then from there, you need to then determine which zeros to count. So now, if we go back to the numbers, let's look at how this would work here. If we look at the first number, 432, there's no decimal present. So I start counting from the right. I skip any zeros. There are no zeros, so I count all these digits. There are 3 sig figs. The next value, 730. There's no decimal present. I count from the Atlantic Ocean, from the right. But now I skip this zero over here. That leads to me to have 2 significant figures. This next number, there's a decimal present. I count from the left. The first number is not 0, I count it. Next number is not 0, I count it. The third number is a 0, but I've already started counting. It's not a leading 0. That gives me 3 sig figs. Try these 4. Tomorrow in class we'll go through them. A fun way of looking at this, here's the United States. Here's some more practice. So here we have a decimal present, and with the decimal present, we're going to count from the left side. So we count from the left side, the Pacific Ocean, we skip over the leading zeros, we start counting 1, 2, 3, 4. Notice this 0 right here, I'm counting that one. So I'm counting that 0, that's going to be part of my number. I have 4 significant figures, I don't count the leading zeros. Now let's talk about the last thing, and that is how to do operations. Multiplication division's easy. You're only as strong as your weakest link. You're limited by the least accurate value. You round the number to have the same number of significant figures as the lowest number of significant figures in the operation. What does that mean exactly? Well, let's look at this first example. The top number here has 4 sig figs. The bottom number here has 2 sig figs. So I do the math in my calculator. So if I take out my calculator, which I do have right here, and I try this out. So let's give it a try. We're going to do 127.4 divided by 2.0. In my calculator, I get 63.7. But the rule says that I need to round to the least number of significant figures. That would be 2 sig figs. My answer has 3. So I need to round it to 2 sig figs. So that will give me 64. I round up. Let's try the next one. 7 times 2. Put that in my calculator. I don't even need to. 14. That's 2 sig figs. So I need to round this to 1. So the closest number to that would be 10. Now this one over here is a little bit ambiguous. How do I deal with that? Well, one way is to put in scientific notation. 1.4 times 10 to the first. Now I round this number to significant figures. One significant figure would be 1 times 10 to the first. That's the same as 10. Significant figures and scientific notation go together. It helps you to get rid of any ambiguity. Finally, if we add and subtract, we round to the least number of decimal places present in the actual number. That's how many we're going to round to. So let's look at how this works. We subtract these two. So we do 2.45 minus 1.1. So that's 6, that's 5, that's 3, that's 1. My first value, the 2.456, has 3 significant figures, or 3 values after the decimal, excuse me. The second one has 1 place after the decimal. So I will round to 1 place after the decimal. I'm going to round to the 10th place. So now when I do this, I get there's a 5 next to it, so it's 1.4. Done. Know these rules. When you multiply and you divide, then you round to the least number of significant figures. When you add and you subtract, you round to the least places of decimals. Thank you for watching this video. This is our last video in this chapter. Your test is going to be soon. We're going to practice some problems in class, and hopefully you'll be ready. Thanks so much.